Okay, let's make these LEDs work. Let's get that real feedback. So what would it mean to turn on the light? Why would we want to turn on one of those LED lights? What would be the condition?
When the coordinates match, when the current coordinates match what's in our storage box.
You got it, dude.
Not based on which button we pressed.
Affirmative. So that actually is a really good point to point out. We want it to be as real as possible. And it being real as possible means comparing as close to the source of truth as we can. So it would be really fast and easy to simply, well, I poked a button, so turn it on. It would, okay? But here's even better, right? Kind of like those BTN presets that we had in the lighting controller. They illuminated when the source of truth matched, not just when they got poked. We want to do the same thing here. So, like Nate said, it's when what's saved in the box matches the current actual PTZ coordinate. Now, we can go ahead and use our imagination, and while we can't necessarily already know how frequently we're going to want to run these comparisons, we can probably already imagine that it's going to be more than once. So let's make it a function, and then we'll figure out where all we want to call those functions. Okay, so let's make a function. Let's call it function func LED feedback. It doesn't need any arguments. Because I opened it, I am closing it. And what do we want to do? We know we want to do this comparison thing. What else do we want to do inside of there? We've got 3 buttons, right? We need to do 3 comparisons.
But we want it to be scalable for more than just 3.
We want it to be scalable, right? So how do we do scalability?
Sounds like another for loop.
You got it. Yeah, we want to do for each LED, we want to, kind of like func interlock, we want to set the dot Boolean according to the comparison.
Sure.
Yeah, all right, so let's try it out. All right, for loop. We're getting good at this.
Yeah.
For I, comma, CTL in I pairs. On which table? On controls dot LED match all of them, not just the particular one. We're going to do the following. All right, and so I closed it, Nate, and I put a little note that I closed the for loop.
I did that as well.
And I indented.
I also did that.
Okay, good. He's learning. All right, and then I indented again, and let's write it out. Set the Boolean according to the comparison. So which Boolean is it? It's CTL's dot Boolean is going to be set equal to the comparison. And I'm going to put the comparison in parentheses. And that's really primarily for me as a human when I read this to be like, okay, it's equaling the output of this comparison. So there we are. What is our comparison going to be? It's going to be controls dot the storage at eyes dot string, and we're going to compare it with devcams ptz dot preset with its string. There we are. CTL.Boolean is going to be equal to the comparison of what's in the box with what's on the camera, right? Is the string in the box matching the string in the camera? When they match, turn on the light. And because we wrote it inside of a loop, we only had to write it once, and perfectly scalable. You want 3, you want 30, you got it. Okay. When do we want to do this? Well, when we start the script. It's always a really good answer. So that's a good answer. So func LED feedback, we'll do it when we start the script. Right? So at startup. When else?
As soon as we release the button or after it loads.
After we after we save.
After we save or load. So
Okay.
after the entire loop that we wrote earlier. At the end of the loop.
All right. So we'll do it when we let go of the button.
Sure.
I think, all right, I'm going to put mine right there in between the end of if button Boolean and end of the event handler. Should be okay. We can do that there.
That seems right.
All right, that's fine. When else? Ooh. Because remember, so far, we're telling it to run this function when our script causes a change. What if somebody just goes and adjusts the camera directly?
Yeah. So if that strings event handler goes, right?
Okay. Yes, that is a good. So I'm only pausing for just a second. We talked about being as close to the source of truth as possible. On our NC series of cameras, there is actually two controls here that are worth our consideration. There is the control called isMoving and the control called moveCompleted. The very best option for us to use is moveCompleted. That is the very best control to consider. But there's a caveat. The caveat is that isMoving and moveCompleted, again, in the sense of being tied to the closest source of truth, is actually tied to the motors in the camera, which means that it won't work in emulation. Because in emulation, there are no motors actually moving. So here's what I mean. If you're really going to deploy this script, and honestly, there's no reason why you couldn't, it will be largely fine. You should consider tying the event handler to the moveCompleted LED, but it won't work in emulation. So because of that, let's actually do what Nate suggested, which is tie to the PTZ coordinate. Now, let's actually do one thing in Func LED feedback. Let's put in this particular line, print Func LED feedback ran. So I'm going to show you something. All right. And now let's write that event handler that we were talking about. So dev cam bracket quote ptz.preset dot event handler equals Func LED feedback. All right. There's that. Hit save and recall your presets. I'm at preset number 2. And I can see that I already have my second LED turned on because of where we called Func LED feedback. If I recall preset number 1, notice two things. One, the camera moved, the LED turned on. That's beautiful. Now, here's another reason why I would encourage you to tie to isMoved, or sorry, to moveCompleted instead of to the PTZ preset string. Notice your debug window. Why does your debug window look the way that it looks, Nate?
Because every time it goes through any decimal change in any of those very long, potentially decimal-filled coordinates, that counts as a change.
It
and
counts
you don't
as a
want
change.
to flood your debug with that.
It's worse than that. Not only does it change, and call event handler, our event handler running a loop. So we are actually looping upon looping upon looping upon looping upon looping upon looping upon looping. There's nothing wrong with running a loop. It's not great, though, to run loops upon loops upon loops upon loops upon loops upon loops. Not because the hardware can't handle it. The hardware handles it just fine. You saw it work. It works just fine. This is more from a just a pure coding principle standpoint of we should run loops as infrequently as possible because loops are expensive. Like, they're wonderful tools, We should use them at every possible turn, but we should use them responsibly. So it's fine. It's working fine. You don't need to really worry about it. But as you think about getting things even bigger and at larger scales, they are considerations worth thinking about, right? Again, this is one of those computer science kinds of conversations about which algorithms are better than others. The control of time to move completed means that we're only going to run that function that calls a loop the one time when we actually need it to do it. But again, because we're emulating, we've got to do what we got to do. And again, it's really fine. I'm making a philosophical point, not a practical point. All right, Nate, it's time for you to whine.
Time for me to whine?
Yeah.
Whoa, this took so long.
Nope, not that one.
Cabernet.
No, not that wine either. No, it's the first kind of wine, but different topic.
This isn't really press and hold at all. This is press and hold and release. If it was just press and hold, this would happen like while you're still holding it. But
you're correct.
Yeah.
This is indeed technically press, hold, and release. So what if I told you it's a simple copy and paste moving of like 2 lines of code to make it be press and hold?
Go on.
Oh, you tell me, smarty pants.
Let's see. So it would mean that the things that happen currently when the release occurs, which would be in the array of flags else section, you'd want to take that out and move it to just when the timer event handles.
Almost. We want to immediately save. We don't want to have to wait for the release to save. You were about to move the recall.
Oh, yes.
Yep.
Yes.
Yep. So what Nate is saying is actually and in fact, here's what I'm going to do. I'm going to copy, and then I'm going to comment this out so that you can see that that's where it came from. And all we're going to do is move it up here into, and I'm going to leave it all disheveled like that. Again, it won't matter, but this way you can see, oh, that looks really out of place. It's because I want you to remember that this is out of place. But hit save, and let's give this a shot. We will make some other sort of, there's that thing. And watch your save box down here. Press, and after 1 second, boom, I'm still holding it, but it already populated the text box. That's press and hold. And you also saw that it also lit up the light.
Which is some nice feedback too. I mean, you think about like when you're saving your radio station in your car, you press and you hold it, and then you get like a beep after you've been holding it for 2 seconds, a little bit of feedback from the device that says it's done the thing. I mean, you could do that too. You could play like a little audio file that goes beep when the timer elapses. You can probably figure out how to do all those things on your own now. We're not going to go down that rabbit hole.